What happens if you have a function in the derived class that has the same name as a function in the base class? Well, that's what we are going to discuss in this video, and we'll start off with overriding base class member functions or redefining base class member functions. Okay, so a derived class member function with the same signature and return type as the base class member function overrides or redefines the base class member function. And the base class member function can also be extended in the derived class. So in the body of the function that you are redefining in the derived class, you can use the fully qualified name of the base class to call its member function. Alright, so you have base class name, the scope resolution operator, and then the member function that you want to call, and that will call the base class version of that function. And then you can add additional statements in the redefined function that are specific or specialized to the derived class. And of course, this is also useful if you want to keep base class member variables private instead of protected or public. A simple example in Visual Studio, again, I have a base class and a derived class which publicly derives from the base class. Alright, in the base class, in the public section, I have a constructor with a default argument, and then I have this toString function which is simply going to print out base class with a new line, and then it's going to print out the value of x. X in this base class is protected, so I can access it in the derived class. Now we might change that later on in the video. Then I have the derived class. This also has a constructor. Derived has a private member, y, which is specific to the derived class. Okay, so we are going to initialize x and y using this constructor, and we do x by passing that xp parameter to this base class constructor, which will construct the base class part of the derived class. And then for y, we simply pass it the y parameter, okay, and that's going to initialize this private y member. But you can see for both classes, we have the toString function for base and then in the derived class as well. In the derived class, this is going to override or redefine the base class toString function, and it's going to print out derived class, new line, and it's going to print out x. We can access x here because again x is protected in the base class, and then it's going to print out y as well, following another new line. Okay, in main I construct base and I'm passing 3 for the construction, and I have derived as well, and I'm passing 33 and 55 for the construction. And I can do something like this. I can do base.toString and I can do derived.toString. We get base class printed out, 3 for x, derived class, 33 for x, and 55 for y. I'll go and comment out this toString function in the derived class. Now, because we do not override or redefine the toString function in the derived class anymore, you can start to think what's going to happen on this statement. Pull and run that, and we get the base class version printed out twice. Base class, it prints out 3, and from the derived class we actually get the base class 1 printed out again, and that prints out x is 33, and as you can see we do not get the y component. Uncomment that. So as you can see, redefining is very useful, but what's also useful about this is I can keep this member private. So I make x private in the base class. Then of course I won't have access to that x member anymore. You'll see we get red squigglies. So what I can do is I can remove some of this code. Something like this. So the derived class only prints out the members that are now specific to the derived class, in this case y. And to get the x member, which is going to form part of the base part of the derived class, you can do something like this. Okay, so it's going to call that toString function of the base class, which is right here. So it's going to print out base class and the x member. And then in derived, we simply print out the members that are specific to the derived part. Okay, so you can see why this is useful. We keep this encapsulation if you want to keep those members private. Okay, and as I mentioned, this toString function in the derived class, it not only redefines the base class version, it also extends it because it calls it right here, and then it adds another statement to it right here. Back to main again, I do base.toString and derived.toString. So let's see what we get. For the base object, we still get what we expect, similar to the previous section, base class, and it prints out x is 3. But look at what we get for the derived object now. It prints out the base class part, base class, x is 33, and then it prints out the derived class, y is 5. Okay, so you sort of encapsulate your data and your functions, and in this way, in your toString or some getter, this could have been some getter as well. I just use toString here as an example, but this could have been some getter as well. So base class function gets the members that are specific to the base class part, and the same with the derived class that is going to operate on or get or set, whatever your function does, the members that are specific to the derived class. And this is what is useful about redefining functions and extending functions in derived classes. Let's talk about function hiding. A member function of a derived class hides all the functions in the base class with the same name, and that means only the member function of the derived class can be called directly, right, using the dot or the arrow operator. Now, just because those base class functions are hidden does not mean that they are inaccessible. Okay, the hidden base class member functions can be called by fully qualifying their names using the scope resolution operator. You can see a quick example at the bottom of the slide. Right, so I have some object, some instance, then you do the class name, so base class for example, followed by the scope resolution operator and the function that you want to access. Okay, I have a different example for you here. I have a class character. In the public section I have a constructor. This has two protected members, health and armor, and so the constructor will initialize those. Then I have these functions, set stats. Okay, let's say we have some character in our game and we want to set the stats on that character. Then we can use these functions. The first one has one parameter and that is going to set the health. Then I have another one here which is going to set both the health and the armor. Then I have a print stats function which is simply going to print out the health and the armor. So this character class is just a general class that we can derive from to create more specialized characters such as a player character, an enemy character, and so on. And that is exactly what we are going to do here. So I have a player character which publicly derives from character. I have a constructor which is going to call the character constructor, alright, to initialize the character part of the player character. Then I have the set stats right here again, but this time we have an XP member variable. See, in the private section we have a XP member variable. So in the player character you'll notice we have a different set stats function. Okay, it has three formal parameters, a health parameter, an armor parameter, and an XP parameter, which is used to initialize the health, the armor, and the XP. Now XP of course stands for experience points in something like a role-playing game, and it makes sense for your player character to have something like that in many different types of games. And typically when you have a character that has an XP component, they usually have a level as well. But just to keep things simple, I don't have that here in this example, so we just have XP. But the point here is that in the player character, we have this setStats member function. And then in the character class, we also have these two setStats functions. Now in the player character, we also have a print stats, and that's going to print out the health, the armor, and the experience as well. Okay, in main I can construct a character. I'll just name that NPC for non-player character. Some non-player character or AI in your game may only need a health component and maybe an armor component, or maybe a level as well, depending on the game, but you probably don't have to keep track of the experience points for a non-player character in your game. Whereas for a player character, it makes sense maybe to have an experience points variable. If you do npc.setStats, then you have access to these two overloads. So we have a setStats function that accepts one argument, right, a health parameter which is going to set your health. And then we have another overload here which will take in two arguments, one for the health and one for the armor. Then we can do something like this. We can do npc.printstats. That prints out the health and the armor. Comment this out. Then next we construct a player, which is a player character. With that text caret between the parentheses, you can press Ctrl, Shift, and Spacebar to see the overloads that are available. And you can see we only have one here, one to set the health parameter, the armor parameter, and the experience parameter. And you might be thinking, wait a minute, why don't I have three overloads here? I should have one for health, then also an overload for health parameter and armor parameter. Those two are defined in the character class. And then also the one in the derived class, which is the player character, the one that accepts three arguments. Well, that's not the case because we have this one right here, the set stats right here in the player character. is not really going to override the ones in the base class, which in this case is the character class, and it's also not going to overload it. So in other words, you are not going to have access to all three in the player character. What it's going to do instead is it's going to hide the ones that are in the base class, or the parent class, in this case the character class, right? So it's going to hide these two overloaded setStats member functions in the character class. So those two are hidden now. Okay, so what we can do is player.setStats. We can do something like this, player.setStats, and pass it those three arguments. And then we can do player.printstats. It works fine. We get health, armor, and XP. Remember that the printstats here is going to actually override or redefine the printstats function that was here in the character class. And that's why we also get the XP component printed out. But let's say we go and remove those two arguments, because I really only want to set the health. Maybe I take some damage. Maybe I set that to 50. But you'll see we get a red squiggly here, too few arguments in function call. And that's because only this one, only the setStats that accepts 3 arguments are directly accessible to objects of player character. And that's because again it hides the ones, okay, these two ones in the character class. But there is a way around this, as I explained in these slides. Just because those member functions in the base class, in this case the character class, are hidden to the derived class, does not mean that they are inaccessible. So we can do something like this, player dot the base class, which in this case is the character class, the scope resolution operator, the function that we want to call setStats, and then Control-Shift spacebar. We can see the overloads that we have available, one that accepts an argument for the health, and then another one that accepts 2 arguments, one for health and one for armor. So let's say we only want to set the health, and we pass in 50 like this, for example, and build and run, and this will work fine. Okay, so we get health is 50, and then armor and XP will be 0. And that's just because of how the constructor works. The constructor is going to initialize the armor and the experience to 0. And the health actually to 100, so you can see it reduced that from 100 to 50. Or in other words, it modified the health member variable to 50. And another thing, this player.printstats, of course player is of type player character, so it's going to use this printstats, which again is a redefinition of the printstats that we have in the character class. So what we can do here is we can do player.character, the scope resolution operator, and printstats. That is then going to print the base class version or the character class version of printstats, and that is only going to print out the health and the armor. As you can see, we only get the health and the armor and not the experience. And it prints out the health component properly. We got 50 there. Okay, so just to reiterate on this, just because you hide the member functions of the base class, in this case the character class, that is in the case when you define member functions in the derived class with the same name. Okay, so just because the base class versions are hidden does not mean that they are inaccessible. And the same with this one, just because you override or redefine a member function in the derived class, that also does not mean that the base class version is inaccessible. Alright, you can do the fully qualified name to get access to the base class version of that function. That is going to wrap up this video. I'll see you in the next video.